Question 1. The fundamental question is Garcia is designing an HVAC system for a large commercial building located in a humid climate. He notices that the psychrometric chart shows a significant latent load due to moisture infiltration through poorly sealed windows and doors. Considering the building's ventilation requirements and ASHRAE standard 62.1, what should Garcia prioritize in his design to effectively manage latent load while maintaining indoor air quality? Increase sensible cooling capacity and rely on dehumidification coils to remove moisture. B. Incorporate dedicated outdoor air systems, DOAs, with energy recovery ventilators to handle latent loads separately. C. Reduce ventilation rates below ASHRAE minimums to minimize outdoor moisture ingress. D. Use a variable refrigerant flow (VRF) system without supplemental dehumidification. Answer. Correct answer. B. Explanation. Garcia must comply with ASHRAE 62.1 ventilation rates to maintain IAC. Simply increasing sensible cooling won't adequately address latent loads, leading to occupant discomfort and mold risk. Reducing ventilation below minimums. C. Violates code and compromises IAC. ERF systems. D. Provide efficient cooling but typically don't handle latent loads effectively alone. Incorporating DOAs with ERVs. B. Allows separate latent load control, improves energy efficiency via heat recovery, and maintains proper ventilation. This aligns with modern design best practices emphasizing humidity control and ventilation separation per ASHRAE 62.1 and 90.1 for energy efficiency. Question 2. In light of recent developments, a designer named Patel is selecting a pump for a chilled water system with known system curve characteristics. The pump curve and system curve intersect at multiple points, but the system is prone to unstable flow rates during part load conditions. Which pump selection or system design strategy best addresses this issue to maintain stable operation? A. Choose a pump with a flat curve and install a variable frequency drive (VFD) for flow control. B. Select a pump with the steepest curve to avoid multiple operating points. C. Use a constant speed pump and throttle the discharge valve to control flow. D. Select a pump oversized by 25% to ensure flow exceeds peak demand. Answer. Correct answer. A. Explanation. Multiple intersections of pump and system curves can cause unstable flow due to operating at multiple points, risking system inefficiency and noise. Selecting a pump with a flat curve A reduces the risk of multiple operating points, coupled with AE flow can be precisely modulated to meet load without throttling, which wastes energy. C. A steep pump curve B may reduce multiple intersections but results in poor part load efficiency. Oversizing pumps D wastes energy and may cause cavitation. Variable speed control is the preferred solution per hydraulic design principles and energy standards like ASHRAE Guideline 36. Question 3. Given the circumstances, ISTA is tasked with designing ductwork for a large industrial facility requiring both high airflow and minimal noise. He considers using round ducts for main trunks but rectangular ducts for branch runs. From the perspective of airflow dynamics and noise control, what should guide his duct material and shape selection? A. Always use rectangular ducts as they are easier to install and insulate. B. Use round ducts in main runs for lower pressure loss and reduced noise, and rectangular ducts in branches for space efficiency. C. Use only round ducts throughout because rectangular ducts increase static pressure losses significantly. D. Use flexible ductwork extensively to reduce vibration and noise. Answer. Correct answer. B. Explanation. Round ducts. B. Minimize pressure losses and noise due to smooth airflow and fewer edges causing turbulence. Rectangular ducts can be space efficient in branches, fitting tight spaces. Rectangular ducts increase pressure loss but are sometimes necessary. Flexible ducts D. Are prone to higher pressure drops and noise and are not recommended for main trunks. The ASHRAE handler. HVAC systems and equipment recommends round ducts for main trunks to optimize energy efficiency and acoustic comfort, supporting this balanced approach. Question 4. Considering the evidence, Singh is analyzing an HVAC refrigeration cycle that uses R400 TINA as the refrigerant. She notices the compressor's discharge temperature is consistently higher than expected, risking lubricant breakdown. What design or operational changes could best mitigate this issue while maintaining system capacity? A. Increase the condenser size to improve heat rejection and reduce discharge temperature. B. Switch to a single-speed compressor with lower compression ratio. C. Reduce refrigerant charge to lower system pressure and temperature. D. Add a liquid line filter dryer to lower discharge temperature. Answer. Correct answer A. Explanation. High discharge temperatures often indicate insufficient condenser capacity, causing higher condensing pressures and temperatures, stressing the compressor and lubricant. Increasing condenser size A improves heat rejection, reducing discharge temperature while maintaining capacity. Single-speed compressors B may not solve discharge temperature issues if heat rejection is inadequate. Reducing refrigerant charge C can lead to capacity and system inefficiency. Filter dryers D remove contaminants but do not affect discharge temperature. ASHRAE Refrigeration Handbook explains that condenser sizing is critical to manage compressor discharge temperature and ensure lubricant integrity. Question 5. In the framework of building load calculations, Mr. Ahmed is assessing the impact of internal heat gains from equipment and occupants in a data center environment. He needs to decide the proper approach for accounting for these loads given the intermittent usage patterns. What method best balances accuracy and practicality for peak load estimation? A. Use the maximum nameplate equipment load plus maximum occupant load for worst-case scenario design. B. Apply diversity factors and load profiles based on typical usage patterns to estimate realistic peak loads. C. Ignore internal loads and size based on external solar gain only. D. Use the average internal load over a 24-hour period. Answer. Correct answer. B. Explanation. Using maximum nameplate loads A leads to oversized systems with wasted energy. Ignoring internal loads C. Risks undersizing. Averaging loads over 24 hours. D. Underestimates peaks, risking occupant comfort and equipment safety. Applying diversity factors and load profiles. B. Accounts for intermittent usage realistically, leading to optimized system size and efficiency. This approach aligns with ASHRAE Fundamentals Handbook guidelines on load calculation methodology, emphasizing realistic modeling over conservative extremes. Question 6. By evaluating sensor technologies, Roberts is choosing a temperature sensor for a building automation system BAS designed to control HVAC zones. She must consider accuracy, response time, and environmental factors. Which sensor type offers the best balance of these criteria in typical commercial HVAC applications? A. Thermocouples for their wide temperature range and ruggedness. B. Resistance temperature detectors or EDS for their accuracy and stability. C. Thermistors due to low cost but less linear response. D. Infrared sensors because they don't require direct contact. Answer. Correct answer. B. Explanation or EDS. B. Provide high accuracy, repeatability, and stability, making them ideal for HVAC zone control where precision is critical. Thermocouples A have wide ranges but lower accuracy and are less common for comfort zones. Thermistors C are inexpensive but have non-linear responses requiring complex calibration, limiting widespread use in BAS. Infrared sensors D are useful for surface or remote sensing but are sensitive to emissivity and environmental factors, less reliable for air temperature control. ASHRAE BAS guidelines recommend REDS for temperature sensing in critical zones. Question 7. From multiple perspectives, Istakir must choose between air-cooled and water-cooled condensers for a new office building's roof-to-HVAC system. The building has limited roof space but ample water supply. Which factor should weigh most heavily in his decision considering energy efficiency, maintenance, and local codes? A. Water-cooled condensers generally require less maintenance than air-cooled ones. B. Air-cooled condensers are preferred in areas with water scarcity due to no water use. C. Water-cooled condensers often provide higher energy efficiency but require water treatment and maintenance. D. Air-cooled condensers are more compact and require less structural support. Answer. Correct answer. C. Explanation. Water-cooled condensers C generally operate more efficiently due to lower condensing temperatures, reducing compressor work and energy use. However, they require water treatment and maintenance to prevent scaling and corrosion. Air-cooled condensers B avoid water use beneficial in water-scarce areas, but may consume more energy. Given ample water and limited roof space, water-cooled is more efficient but demands careful maintenance planning. Local codes may restrict water use or discharge. These must be considered. ASHRAE Handbook. HVAC systems notes this trade-off and the importance of site-specific conditions in condenser selection. Question 8. When evaluating the merits of duct insulation materials, Hernandez must select a product for a chilled water piping system in a humid climate to prevent condensation and energy loss. Which insulation characteristic is most critical for this application? A. High thermal conductivity to ensure heat transfer. B. Low water vapor permeance to prevent moisture infiltration. C. High compressive strength to resist mechanical damage. D. Light color to reflect radiant heat. Answer. Correct answer. B. Explanation. In humid climates, preventing moisture ingress into insulation is paramount to avoid condensation and microbial growth. Low water vapor permeance B creates the vapor barrier effect, protecting insulation and pipes. High thermal conductivity A is undesirable. Insulation should have low thermal conductivity. Compressive strength C matters, but secondary to moisture control. Reflective color D is more relevant to surface insulation exposed to solar radiation, less critical inside mechanical rooms. An ASHRAE Handbook. Fundamentals and IMP provide guidelines emphasizing vapor retarders for chilled water piping in humid areas. Question 9. According to recent studies, Owens is troubleshooting a variable air volume valve system that exhibits unstable zone temperatures and poor humidity control. The valve boxes are equipped with standard modulating dampers but no reheat coils. What design improvement would best address both temperature stability and latent load control? They add terminal reheat coils to each valve box for precise temperature control. B. Increase the supply air temperature set point to reduce cooling load. C. Use constant volume system instead of valve. D. Install dedicated dehumidification units or DOAs to handle latent loads separately. Answer. Correct answer. D. Explanation. Valve systems modulate airflow but can struggle with latent load control if reheat is not provided. Adding reheat coils A improves temperature control but can waste energy and still may not address humidity adequately. Increasing supply air temperature B risks discomfort and doesn't solve latent loads. Constant volume systems C are less efficient. The best modern approach is D. Use DOAs or dedicated dehumidification units to manage latent loads separately, allowing valve airflow to control sensible load efficiently. This is supported by ASHRAE 62.1 and the ASHRAE Handbook. HVAC applications. Question 10. Throughout the course of designing a cleanroom HVAC system, Johnson must ensure strict control over air pressure relationships to prevent contamination. Which pressure relationships should be maintained between the cleanroom and adjacent less clean areas, and what is the rationale behind it? A. Positive pressure in the cleanroom relative to adjacent spaces to prevent ingress of contaminants. B. Negative pressure in the cleanroom to contain contaminants inside the room. C. Equal pressure between cleanroom and adjacent areas to allow free airflow. D. Pressure differential is irrelevant. Filtration is sufficient to control contamination. Answer. Correct answer A. Explanation. Maintaining positive pressure A in the cleanroom relative to adjacent less clean spaces ensures airflow moves outward, preventing infiltration of contaminants. Negative pressure B is used in isolation rooms to contain hazards but is unsuitable here. Equal pressure C risks contamination ingress. Filtration alone D is insufficient without proper pressure control. This design principle aligns with ISO 14644 standards and ASHRAE cleanroom guidelines, emphasizing pressure differentials as primary contamination control mechanisms. Question 11. Taking into account a commercial building retrofit, Torres is tasked with redesigning the ventilation system to improve indoor air quality while minimizing energy use. The existing system uses 100% outside air with constant volume fans. According to ASHRAE Standard 90.1 and 62.1, what would be the most effective design strategy to achieve both goals? A. Replace the constant volume fans with variable air volume valve systems and install an energy recovery ventilator to precondition incoming air. B. Maintain 100% outside air, but reduce fan speed during unoccupied hours without heat recovery. C. Switch to 50% recirculated air mixed with outside air to reduce energy consumption. D. Use constant volume fans with demand control ventilation sensors, but no energy recovery system. Answer. Correct answer. A. Explanation. Maintaining 100% outside air. B. Wastes energy if no heat recovery is implemented, reducing ventilation or mixing in recirculated air below code. C. Risks HVACR violates ASHRAE 62.1 minimum ventilation rates. Demand control ventilation. D. Optimizes fresh air but without energy recovery. Wastes heat and cooling loads. Using VAF fans adjusts airflow to occupancy. ERV recovers sensible and latent energy from exhaust air, improving energy efficiency while meeting ASHRAE 90.1 and 62.1. This balances occupant health and operational cost effectively. Question 12. With the advent of new refrigerants, HRConquer is designing system using refrigerant with glide characteristics. From thermodynamic standpoint, what critical design adjustments should be made to optimize performance and avoid efficiency loss due to glide? A. Use larger condenser coil to allow gradual temperature reduction and prevent subcooling mismatch. B. Select expansion devices that accommodate two-phase flow and ensure proper refrigerant distribution. C. Adjust superheat settings to the maximum allowable to offset glide effects. D. Ignore refrigerant glide as it has minimal impact on performance. Answer. Correct answer. B. Explanation. Refrigerants with temperature glide require expansion devices capable of handling variable two-phase mixtures to prevent maldistribution and reduce capacity losses. B. Larger condensers alone won't compensate for glide effects properly. Maximum superheat settings C can lead to compressor damage and inefficiency. Ignoring glide. D. Overlooks its significant effect on heat exchanger performance. Selection of thermostatic expansion valves or electronic expansion valves designed for glide refrigerants is crucial as per ASHRAE Refrigeration Handbook guidance. Question 13. Among the various scenarios HCN is evaluating pressure losses in a duct system with several 90-degree elbows and long straight runs. She notices unexpected high static pressure at the fan inlet. What is the primary cause, and how should she optimize the design to reduce these losses according to duct design principles? A. Use long radius elbows and increase duct size at bends to reduce turbulence and pressure drop. B. Replace all elbows with flexible ducts to reduce sharp turns. C. Use rectangular ducts only to minimize pressure loss at elbows. D. Increase fan speed to compensate for pressure loss without redesigning ducts. Answer. Correct answer. A. Explanation. Sharp 90-degree elbows cause turbulence, increasing pressure loss. Using long radius elbows A. Smooths airflow, reducing turbulence and pressure drop. Flexible ducts B. Often increase pressure loss and noise. Rectangular ducts C. Usually have higher friction losses and are not inherently better for pressure loss at bends, increasing fan speed. D. Wastes energy and can cause noise vibration issues. This aligns with Fundamentals Handbook, which recommends minimizing sharp bends and using appropriate duct sizes to optimize system efficiency. Question 14. Considering the evidence as to Davis's sizing, a chilled water pump for a variable flow system with parallel pumps. To avoid cavitation and maintain stable operation at low flow rates, what design considerations should he prioritize? A. Select pumps with high net positive suction head required in HVACR and install them at the lowest elevation. B. Use variable speed drives and install suction stabilizers to maintain adequate NPSH. C. Oversize pumps by 50% to reduce flow velocity and cavitation risk. D. Use a single constant speed pump and throttle discharge valves to control flow. Answer. Correct answer. B. Explanation. Cavitation occurs where NPSH available falls beyond HVACR, damaging pumps. Pumps with high HVACR are more prone to cavitation. Variable speed drives B. Allow flow matching to load, reducing throttling losses, and suction stabilizers prevent pressure fluctuations, maintain NPSH. Oversizing C. Wastes energy and may not prevent cavitation. Throttling D. Wastes energy and can reduce NPSH further. ASHRAE HVAC Systems Handbook emphasizes variable speed pumping with proper suction conditions to avoid cavitation and improve system control. Question 15. In a modern context of refrigerant safety, is QMI specifying equipment that will use a mildly flammable refrigerant AL classification according to industry standards and safety codes, which critical system design element must be incorporated to ensure compliance and occupant safety. A. Incorporate leak detection systems and ensure proper ventilation per ASHRAE Standard 15. B. Use standard non-explosion proof electrical components without special consideration. C. Rely solely on routine maintenance without additional safety features. D. Design the system without pressure relief valves to avoid refrigerant release. Answer. Correct answer A. Explanation. Our refrigerants require enhanced safety measures, including leak detection and ventilation, to prevent accumulation of flammable gases. A. Per ASHRAE 15 and IC standards, using non-explosion proof components. B. Risks ignition, solely relying on maintenance. C. Is insufficient. Pressure relief valves. D. Are mandatory safety devices to prevent catastrophic failure. Proper adherence to safety standards. Mildly flammable refrigerants protects occupants and complies with evolving regulations. Question 16. From the perspective of energy efficiency, Stein is selecting an HVAC system for a LEED certified building. He wants to maximize the system's seasonal energy efficiency ratio (SEER) while considering peak load demands and part load operation. Which system selection best aligns with these goals? A. Choose multi-speed heat pump system with inverter-driven compressors and advanced controls. B. Select single-speed, high-capacity system to meet peak loads efficiently. C. Use constant volume air handling unit with on-off compressor control. D. Opt for system with oversized ductwork to reduce static pressure losses. Answer. Correct answer A. Explanation. Multi-speed systems with inverter-driven compressors. A. Adjust capacity to match load, improving part load efficiency and increasing SEER, crucial for lead points. Single-speed units. B. Cycle frequently, reducing efficiency and comfort. Constant volume systems. C. Waste energy during part load. Oversized ductwork. D. Reduces pressure loss but increases cost and space without necessarily improving SEER. ASHRAE 90.1 and LEED guidelines favor variable capacity systems for energy efficiency and occupant comfort. Question 17. When evaluating the merits of air filtration for an office building, is new and must select filters that balance particulate removal efficiency and fan energy consumption. According to ASHRAE Standard 52.2, which filter characteristic best achieves this balance? A. High MERV rating 1620 with low pressure drop filters. B. Low MERV rating 14 filters to minimize fan power consumption. C. Medium MERV rating 813 filters optimized for particle size and pressure drop. D. Use only HEPA filters for all HVAC systems regardless of application. Answer. Correct answer C. Explanation. Filters with medium MERV ratings 813C provide a good balance of particle removal efficiency, including fine particulates and manageable pressure drop, reducing fan energy use. High MERV or HEPA 8D offer excellent filtration but cause significant pressure drop, increasing fan energy and costs, often unnecessary for typical office environments. Low MERV B filters have minimal impact on IAC. ASHRAE 52.2 defines MERV and recommends selection based on application and energy impact. Question 18. Upon closer examination, Mr. Wilson is troubleshooting a hydronic heating system experiencing uneven heat distribution and frequent pump cycling. Which control strategy would best optimize flow and temperature to improve system performance and reduce energy waste? A. Implement variable speed pumping based on differential pressure control and thermostatic radiator valves. B. Use fixed speed pumps and manual balancing valves. C. Oversize the pump to ensure constant high flow rates throughout the system. D. Install on-off thermostats controlling the pump operation directly. Answer. Correct answer A. Explanation. Variable speed pumping with differential pressure control. A. Adjusts flow to meet demand, reducing pump cycling and energy use. Thermostatic valves provide local control, improving comfort and system balance. Fixed speed pumps B. Waste energy and can cause noise. Oversizing pumps C. Is inefficient and costly. On-off thermostats D. Cause frequent cycling, reducing equipment life. ASHRAE Hydronic Systems Handbook supports variable speed controls to optimize hydronic system efficiency. Question 19. The underlying principle of duct sizing requires balancing velocity and pressure loss. Alan is designing ductwork for a hospital cleanroom. How should she prioritize duct velocity and pressure loss to maintain cleanliness and efficiency? A. Use high velocity to minimize duct size, accepting higher pressure losses. B. Use low velocity to reduce noise and particulate resuspension while controlling pressure loss. C. Ignore velocity and focus only on duct material. D. Select velocity based on cost savings without regard to air cleanliness. Answer. Correct answer. B. Explanation. Low velocity ducts. B. Reduce noise and minimize particulate resuspension. Critical for clean rooms. High velocity. A. Increases pressure loss, noise, and contamination risk. Duct material. C. Is important, but velocity directly affects system performance and IAC. Cost-based velocity selection. D. Risks non-compliance with cleanroom standards such as ISO 14644 and ASHRAE guidelines. Balancing velocity to optimize cleanliness and efficiency is paramount. Question 20. From a practical standpoint, Mr. Rodriguez is designing a chilled beam system for an office building to avoid condensation on chilled beams in a humid climate. What system design strategy should he implement? A. Maintain supply air at dew point temperature below chilled beam surface temperature by controlling ventilation air humidity. B. Increase chilled water temperature to avoid beam surface temperatures near the dew point. C. Rely on building occupants to report condensation for corrective action. D. Use chilled beams without supplemental ventilation air to reduce complexity. Answer. Correct answer. A. Explanation. Condensation occurs if chilled beam surface temperature falls below the dew point. Controlling ventilation air humidity. A. Ensures dew point remains below beam temperature, preventing condensation. Increasing chilled water temperature. B. Reduces cooling capacity and comfort, relying on occupant reports. C. Is reactive and efficient, using chilled beams without ventilation. D. Risks poor air quality and humid control. ASHRAE Application Handbook recommends active humidity control strategies in chilled beam designs to avoid condensation and maintain IAC. Question 21. The underlying principle of the first law of thermodynamics is vital when sizing the compressor in a refrigeration cycle. Evans is reviewing a vapor compression system where measured inlet and outlet enthalpies indicate a discrepancy in expected work input. Given that energy losses occur due to mechanical inefficiencies and heat transfer to the surroundings, which calculation approach will yield the most accurate compressor power requirement? A. Calculate power using the difference between theoretical enthalpy rise H multiplied by mass flow, ignoring inefficiencies. B. Use the measured enthalpy rise plus an allowance for motor efficiency only. C. Determine power by adding mechanical loss estimates and heat gains to the theoretical enthalpy rise, then divide by motor efficiency. D. Base calculations solely on nameplate horsepower, as manufacturers account for all losses. Answer. Correct answer. C. Explanation. The first law mandates that actual work input equals the ideal enthalpy rise plus all system losses. Ignoring inefficiencies. A. Underestimates power, accounting only for motor efficiency. B. Omits mechanical and heat losses in bearings, seals, and piping. Manufacturer nameplate data. D. May not reflect the specific installation conditions. Correct sizing requires adding estimated mechanical losses, e.g. friction, pressure drop in suction line, and heat transfer into the compressor housing to the ideal enthalpy rise, then adjusting for motor efficiency, typically equals 90%. This approach aligns with ASHRAE Refrigeration Handbook methods for accurate work input determination. Question 22. In light of recent developments in psychrometrics, Mr. Fernandez is analyzing the performance of an evaporative cooling system in a dry climate. The outdoor air enters at 35 dec dry bulb and 10% relative humidity. Considering the psychrometric relationships between wet bulb depression, enthalpy change, and moisture addition, which design parameter is most critical to predict the system's sensible cooling capacity accurately? A. Final dry bulb temperature only, since latent change is negligible. B. Wet bulb depression and saturation efficiency of the evaporative media. C. Relative humidity alone, because it determines moisture absorption. D. Dry bulb temperature rise across the pre-cooler. Answer. Correct answer. B. Explanation. Evaporative cooling relies on latent heat absorption equal to the wet bulb depression multiplied by the saturation efficiency. Final dry bulb temperature A emerges from both sensible and latent effects. Neglecting latent change leads to air of relative humidity. C is initial state but doesn't quantify media performance. Precooler temperature rise. D only addresses sensible change. Accurate prediction of sensible cooling capacity mandates known the wet bulb depression, outdoor dry bulb minus wet bulb, and the media's saturation efficiency ratio of actual to ideal moisture addition per ASHRAE fundamentals psychrometric principles. Question 23. Under the assumption that a cleanroom's air change rate must comply with ISO 14644-1 is Nakamura is specifying air distribution. She must balance high air change rates with thermal comfort and energy use. Which strategy best achieves the required cleanliness class while limiting excessive energy consumption? A. Use high-efficiency particulate air HEPA filters in the supply and recirculate up to 50% of air through parallel HEPA units. B. Increase total air changes per hour beyond standard using simple filters to minimize equipment cost. C. Maintain specified with laminar flow diffusers and install an energy recovery wheel on exhaust air. D. Lower it during off hours and rely on portable air cleaners for peak use periods. Answer. Correct answer A. Explanation. ISO 14644-1 prescribes minimum and filter efficiency to achieve a specific cleanliness class. Simply exceeding it with basic filters. B. Wastes energy and may not capture fine particles, reducing its off hours. D. Risks contamination. Option C recovers energy, but laminar flow alone doesn't address recirculation efficiency. Recirculating up to 50% through HEPA units A reduces outdoor air load, meeting its and particulate requirements while minimizing heat and cooling energy via recirculation. This aligns with ASHRAE cleanroom design guidelines and ISO standards for energy-efficient contamination control. Question 24. When considering fluid flow through refrigerant piping, HRConquer must ensure that the refrigerant maintains adequate velocity to prevent oil logging, but not so high as to cause excessive pressure loss. According to refrigerant piping design standards, what is the optimal velocity range for liquid refrigerant in horizontal suction lines to balance these concerns? A. 0.51 meters to minimize pressure drop and ensure oil return. B. 2.03 meters, which ASHRAE recommends for all refrigerant lines. C. 0.8 1.5 meters, balancing oil carryover and pressure loss. D. 4.05 meters to guarantee oil entrainment. Answer. Correct answer. C. Explanation. Refrigerant piping manuals e.g. ASHRAE Refrigeration Handbook recommend 0.8 1.5 meters in horizontal suction lines for oil return without excessive friction loss. Lower velocities A. Risk oil logging. Higher velocities D. Increase pressure drop and noise. Blanket recommendation of 2-3 meters B. Applies to vapor lines, not liquid or suction lines. Staying within 0.8 1.5 meters ensures liquid and oil mixture, preserving compressor lubrication and maintaining efficiency. Question 25. As illustrated by a TRF installation case, Clark faces challenges in refrigerant leak detection and containment. Which code or standard primarily governs the design and maintenance of refrigerant piping systems to minimize environmental impact and ensure safety? A. NFPA 90A, standard for the installation of air conditioning and ventilating systems. B. ASHRAE Standard 15, safety standard for refrigeration systems. C. ISO 5149, refrigerating systems and heat pumps. Safety and environmental requirements. D. IC 60335, safety of household and similar electrical appliances. Answer. Correct answer. C. Explanation. ISO 5149 focuses specifically on safety and environmental requirements of refrigerating systems, including leak detection, piping installation, and containment of refrigerants. NFPA 90A covers HVAC installation but not detailed refrigerant safety. ASHRAE 15B addresses safety but emphasizes equipment operation and personnel protection. IC 60335D pertains to electrical appliances. Therefore, ISO 5149 is the primary reference for environmentally responsible and safe refrigerant piping design. Question 26. To illustrate this point, Mr. Silva is comparing heat exchanger sizing methods for a condenser operating with R134 East LAD and N2 approaches available. Which method offers better insight into performance under variable flow conditions and why? The N2 method, because it provides performance predictions based on effectiveness even when flow rates change. BLNTD method, since it directly uses entering and leaving temperatures for any flow variation. C. Both methods are equivalent under all operating conditions. D. Neither method is suitable. Experimental correlations must be used exclusively. Answer. Correct answer A. Explanation. The N2 method relates heat exchanger effectiveness to capacity rates and NTU, making it adaptable to variable flow conditions without recalculating log mean temperature difference. LATD requires constant temperature difference assumptions and recalculation of correction factors for cross-flow or mixed flow, complicating analysis under flow variation. While LATD is simpler for steady design point conditions, N2A offers superior predictive capability across operating ranges per ASHRAE heat exchanger design practices. Question 27. Several experts suggest that during a LeadVV energy model review, Vega finds discrepancies in the baseline HVAC system efficiencies. According to ASHRAE 90.1 Appendix G, which parameter must match the baseline model exactly to ensure a fair compliance comparison? A. Fan motor efficiencies, but only at full load. B. Refrigerant type selected in the proposed design. C. Base case equipment size and performance as specified in Tail G.1. D. Building envelope characteristics from the proposed design. Answer. Correct answer. D. Explanation. Appendix G mandates that the baseline building envelope match the proposed design's envelope characteristics. D. To isolate the impact of HVAC efficiency, fan motor efficiencies A and refrigerant type B of the baseline case follow prescriptive values, not the proposed design. Equipment size performance. C. Uses standardized assumptions per Tail G.1, not the proposed selection. Identical envelope parameters ensures that energy model differences reflect mechanical system performance accurately. Question 20. Given the circumstances of a retrofit in an existing high-rise, Mr. Patel must select a control protocol for integrating multiple building automation systems (BAS), which protocol offers open standard interoperability, wide industry support, and minimal licensing restrictions. A. BACnet METP, because it is a proprietary protocol with vendor-specific extensions. B. Modbus to CPEP, as it is open, widely supported, and easy to implement. C. Lonworks, due to its standardization under ISO, vendor neutrality, and flexible topology. D. KNX, which is primarily used in European residential automation. Answer. Correct answer. C. Explanation. Lonworks C is an ISO standard IC 14908, offering vendor-neutral interoperability, peer-to-peer communication, and flexible topologies. Ideal for integrating diverse BAS. BACnet METPA is open but slower and tied to RS 485. A BACnet tip would be preferable. Modbus to CPEP-B is open but lacks built-in device discovery and advanced services. ANX-D is mainly for residential and limited in HVAC controls. ASHRAE recommends BACnet and Lonworks for complex building control integration, with Lonworks chosen when peer-to-peer flexibility and topology options are paramount. Question 29. While examining moisture loads for a museum HVAC design, Rivera calculates latent loads from outdoor air infiltration, exhibit cases, and occupant breathing. Which approach will yield the most accurate total latent load estimation for peak design conditions? A. Some maximum latent loads from each source assuming simultaneous peak. B. Apply coincidence factors to reduce each latent source based on utilization profiles. C. Use average hourly latent loads over a typical week. D. Neglect exhibit case latent loads as they're minor compared to infiltration. Answer. Correct answer. B. Explanation. Assuming simultaneous peaks, they leads to oversized equipment and wasted energy. Average loads. C. Underestimate peak demands, risking humidity excursions and exhibit damage. Neglecting exhibit loads. D. Ignores significant sources of moisture from display lighting and porous materials. Applying coincidence or diversity factors, B. Per ASHRAE fundamentals and ventilation standards reflects realistic simultaneous peak conditions of infiltration, exhibit case outgassing, and occupants producing an accurate latent load, proper dehumidification capacity. Question 30. For the purpose of evaluating environmental impact, Mr. Yamaguchi is assessing the life cycle climate performance (SCP) of two chiller options, one using R134 and another using R513. Which factor most significantly influences the SCP comparison, and how should it be quantified? A. Initial cost difference, because capital expenditures drive sustainability decisions. B. Refrigerant global warming potential to be multiplied by the estimated annual leakage rate and lifetime charge. C. Compressor isentropic efficiency as it dictates seasonal energy use. D. Condenser fan power consumption under full load conditions only. Answer. Correct answer. B. Explanation SCP accounts for both direct emissions, refrigerant leak debut, and indirect emissions, energy consumption. The factor with the largest impact is the refrigerants to be multiplied by its expected annual leakage and total charge over design life. B. Initial cost. A. Doesn't measure climate impact. Isentropic efficiency. C. And fan power. D. Affect indirect emissions but are secondary to refrigerants due to pure contribution SCP calculations per ICD 213 and ISO FDIS 81734 methodologies.